Hello everyone, this is Saidat from AML and my TED Talk topic of artificial intelligence and expert system is explainable AI. We'll call it as XAI. Initially, how does it works? How AI will works? We'll see. Audience measurement system. The output will comes as the customer will churn and accounting compliance system. This transaction will be risky, but we don't know. We have given the input and we have get the output. We don't know how does it works. We'll see how it works. In AIS black box, if AIS black box, what black box AI do means, why did the AI system do that? Why did the AI system do something else? When did the AI system succeed? When did the AI system fails? When does the AI system gives enough confidence in the decision that you can trust it? How can the AI system correct an error? If the AI system has a black box, we'll get the solution for these questions. So, AI system, we are entering a new age of AI applications. Machine learning is the core technology, and the machine learning models are opaque, non-intuitive, and difficult for people to understand. Now, AI will give the solution, but it is very difficult to understand for the people's. Now, the user has a doubt that why did you do that? If the AI system given a solution, the user will think like, why did you do that? Why not something else? When do you succeed? When do you fail? When can I trust you? How do I correct an error? These will get to the user. XAI, this is expandable AI, full circle of life. User, this is user. Augment, explainable techniques. By using, we'll use explainable techniques, then it will interprets and it will interprets. And the black box model, we have the black box model, and we will train the data and capture the world. Here we have users and augments by using the explainable techniques. Interprets by using the black box model, and it trains the data and they capture the world. This is the full cycle of life. There are three key pillars for the explainable AI. First one is reasonable AI, the ability to understand the reasoning behind each individual prediction. It can able to understand each individual predictions. Next, traceable AI, the ability to trace prediction process from logic of maths algorithm to nature of data. It can trace from the algorithm to understandable by the users. Next, understandable AI, the ability to fully understand and the model upon which the AI decision make is based. These are the three key pillars for the explainable AI. Principles of expandable artificial intelligence. First one is designing AI with an eye to societal impact, defining standards for the provenance, use, and securing of datasets. Next, testing AI extensively before release, using AI transparently, monitoring AI rigorously after release, fostering workforce training and retraining, protecting data privacy, establishing tools and standards for auditing algorithms. Limitations for XAI. Features importance. Most modern analysis stays in finding the important features, but they largely ignore the interactions between the features. Problem domain. Each business model has its domain. nuisance and has defining contribution to the explainability model analysis improves the less of it the outcomes of explanation will blur or too generalized. Data pre-processing dimensionality reduction, word vectorization, etc. Obscure the original human meanings and make data less informative. Correlated input features. During feature analysis and selection process, most of the correlations are either dropped to improvement accuracy or swamped by other powerful features with more predictive power. This hides the latent correlation factor from model and leads to incorrect explanation. Type of prediction. Straightforward binary or ordinal classification and linear regression models are easier to explain. They have natural direction for decision. However, models like classification do not have inherent order or in difficult to explain unless it comes to one versus all model. Business benefits from the XCI. We have the 4 business benefits from the XCI. First one, optimize model performance based on the model performance and decision making. It is very optimized and retain. It controls and very safety. It gives the safety decisions and maintain. We can trust the XAI and ethics, compel accountability and regulation. Current state of AI models with respect to explainable AI versus performance. These are the learning techniques today. Neural nets, deep learning, statistical model, AOGs, SVMs, graphical models, Bayesian belief nets, and Markov models, ensemble methods, random forest decisions. These are the learning techniques. And this is the explainability. This here explainability versus prediction accuracy. We can see here the regression multinomial equations can be messy. Random forest multi-trees and their data sets and voting. SVM kernel and data partition effects on features. K-means nature of centroid doesn't describe cluster well. NN hidden nodes and their way of creating features. Techniques for XAI. Model specific techniques deals with the linear working of algorithm or model to interpret its results. Model agnostic techniques deals with analyze the features and its relation with its output. Here you can see data. For model specific techniques, we'll give the data to the model and it will give the prediction and explanation. And we have another technique, model agnostic techniques. In this, we'll give the data to the model and magic, and it will give the prediction and explainability. Model specific versus agnostic approach. The major difference between these is everything is same, but in this we use algorithm slims, gains, and rule. In this we'll use algorithm limes. We'll see what is slims and lime. XAI model specified techniques. Tree interpretation. Decision tree is most interpretable algorithm because it's simple information gain mechanism of building the tree. Random forest on other multiple small trees and with dataset variations and vote for final decision which is based on majority. There are open source project tree interpreter available, but deep domain and deep algorithm knowledge are required to study its output. We will see here slim means super sparse linear integer model. Super sparse linear integer model is a discrete optimization problem that minimizes the 0 or 1 loss to encourage a high level of accuracy, regularize the norms to encourage a high level of sparsity and constraints coefficient to a set of interpretable values. Deep neural network. Deep lift, a method for decomposing the output prediction of a neural network on a specific input by backpropagation, the contribution of all neurons in the network to every feature of input. Deep lift compares the activation of each neuron to its reference activation and assigns contribution score according to the difference. Using this can give important sequence of input data. Model agnostic techniques, sensitivity analysis. It tried to analyze the effect of single input feature alteration on its model output. This gives linear approach of model response. This approach is often extended to partial dependence plots or individual conditional exceptions plots to give global graphical representation of single. Local interpretable model explanation. This is the line. It's tried to find out future importance by capturing future interactions, correlations, and covariance analysis between the features and outputs using a linear model between features. It used perturbance technique, which observes prediction deviation based on one feature modification. Shapely additive explanation is an additive feature attribute methods which assigns a value to each feature for each prediction, that is feature attribution. The higher the value, the larger the features attribution to the specific prediction. Feature status of exercise systems. New approach create a suite to machine learning techniques that produces more explainable models while maintaining high level of learning performance. These are the learning techniques that we have discussed, and this is the explainability. From this, we'll get the deep explanation, modified deep learning techniques to learn explainable features, interpretable models, techniques to learn more structured, interpretable causal models, model induction, techniques to enter an explainable model from any model as a black box. Thank you.